Hello audience. In this video we're going to start putting this thing back together. So the next step is to start welding in the new sills. Now before we do that, we need to establish that the rest of the body is sitting square and even and is not bent up. And we also need to establish that the frame is not damaged in such a way to where it's holding the body at an awkward angle. Now because of the way the collision was, it was hit hardest on the left rear. The most likely damage that could have happened from the collision is the frame could be angled. The left rail could be slightly further forward than the right. Now we checked that, it's not. I also checked it to see if the frame is twisted. It's not, it's setting level front and rear. Now there's a lot I can talk about with frames. I can't really condense it down to a few sentences. So what I'm probably going to do is make another video later on just Model A frames and the typical problems they're prone to and how to look for them, and also the ways I checked this frame. Now, I'm not going to say this frame is absolutely perfect in every way and we checked everything that could possibly be wrong with it. What I am saying is it doesn't have any damage from the collision, or at least that can be measured, that's going to affect the way the body mounts to it. So the next thing we need to do is start measuring the body and see if that's sitting square and level. Another thing I'll point out is while we're doing all these measurements, it's important that the car is sitting on a reasonably level floor. Like this is a garage floor, which is pretty good, as opposed to a crooked driveway or the side of the road or something like that. Another thing is I have the car held on jack stands right now, just in case one tire is inflated more than the other, or if one tire has a slow leak. Over the course of a few days, that side of the car can lean over and that can affect measurements. I've learned that the hard way. Also, I have the jack stands under the axles, not the actual frame. Now, the reason I did this is because the springs are holding the frame and the weight of the body and the engine is between them, so the frame's under stress the way it normally is. Now, if I put the jack stands on the frame rails, not only would the cross member be not under stress from holding the car, it would actually be stressed the other direction for holding up the weight of the rear axle. It probably wouldn't change it very much, if even at all. We're probably overthinking it a bit with this car, but that is very critical with other cars. Like for example, a lot of the full-size convertibles from the late 50s and 60s, the body will have a lot of overhang behind the rear axle. And because they have no roof structure, if you jack up the car at any point in front of the rear axle, it can open up the door gap, it can change the body dimensions around, and that's really critical if you're replacing the quarter panels on them or something, because you adjust the door gap while it's being suspended, then you put the car back on the ground and the gaps close up. But like I said, probably just overthinking it with this car, but it will work this way. Now the first thing I checked on the body was I took a level and checked it across all three cross members, and I checked it in the center, on each side, flipped it around, and they all read about the same. I don't know if you can really see that, but it's just about in the center, which is pretty surprising. I figured they would be off a little bit. Now what we're really looking for is to see if one of them is noticeably leaning in one direction from the others, and none of that is present. Another thing I did was took the tape measure and I measured between the second and third cross members in an X pattern and discovered it is off by about 1/16 of an inch in this direction. Now, that could just be from the way I measured it. It could also be made that way. Anything up to about an 1/8 inch or 3/16 inch, it could have been made that way because that's within tolerance, so I'm not going to worry about that. I measured the overall height from the cross member to the top of the trunk, and it's exactly 21.5 inches on both sides. Also measured from the other cross member to the top, and it's exactly 31 1/4 on each side. I measured from the sill on one side to the quarter panel on the other side, and I discovered the entire body's leaning over to the left about 1/4 of an inch. I don't know if that's from the collision or it's just sitting that way because we removed so much structure from it. Either way, I'm going to have to rig up something to hold the body in place evenly while we start reconstructing it. Alright, it's even now. So now we're going to start mocking up the new sills. And if you're wondering, why is it important that the top of the body be aligned while we're making the sills? It's because we're going to base a few measurements off of the top of it. So it's important that that's in the right place. I made a little adjustment on these sills. I welded another piece of metal inside it so that it'll be double walled. And then I drilled a couple of holes in the original sill so I can weld it from the outside. And it's all mocked up, ready to go. Now I got a clamp on each end holding the sill on. I ran a straight edge across the old sill, make sure the new one's parallel with it. I have a body block under each one where they should be. Now this one I had to trim down a little bit to make them parallel. Now I measured them from this cross member to the back, and it's even on both sides. I also measured in an X pattern in this way so it's not leaning over to one side or the other. The width of this determines how far apart the sills are. There's nothing I can do about that. And I measured from up here all the way back to here, and that's even. Also, a really big important thing to do with these is to just put the measuring tape down and look at it to see if the cross members are parallel with each other. And to see if the sills are parallel with each other. Now we're working on securing the quarter panels down, and I discovered this one on the left side, it's too far back. Now I measured the opening for the fender and it is more on this side, so this whole part of the quarter is further back. Also, I made a pattern of this curve here, and this part of the panel is actually pushed up a little bit compared to the other side, so there's actually more curve in this. So we'll have to do something about that, but I'll worry about that later after I secure the quarter panel on. Another thing I discovered is, if you look at the right side quarter panel, just kind of look at the general shape, then look at the left, it's noticeably flatter, especially around here. So I installed this apparatus to pull the back of the quarter panel in, and watch what happens to the side of it when I start tightening it up. And now it lines up pretty good. Now this may be bowing out a little too much now, but when I weld it together and release the tension on this thing, it will retract a little bit, so it's probably about right now. So now I'll start welding it in and see what happens. Now it's looking pretty good. Now this area in here is, so you can see it's cracked open there, so I'm just going to cut this out and make a patch panel for this area, and then we'll go back to welding it in. Alright, I got that welded on mostly. Now this was pretty tough to weld on because since it had already been brazed in here, any contamination like brass or solder on steel makes it really difficult to weld. Also, it's probably been ground a lot because the metal's like paper thin in some areas, so the welder just blew holes in it quite a bit. But I did get it attached. I also welded it inside good as I can and attached it to the rear cross member. Now that part over there, I'll worry about patching that when we start putting the wells back in. So now it's time to release the tension on it and see what it does. Well, it's looking pretty good now. This part of it did go back down a little bit, so now it looks about the same as the other side. It's not flat across here like it was. Now there's still a lot that needs to be done. This is kind of beat up here, but it's going to be easier to work on now that it's anchored down. Anyway, that's it for this video. Thank you very much for watching. We'll see you in the next one.